So that was the last topic which we were discussing. That was regarding the agent types. And the first type, as you can see on the slide, is called the simple reflex agent. And why we call it simple reflex agent? Because there is no need to think about whatever the situation you have, whatever the agent perceives from the environment. Basically, it is represented in terms of what the world is like now, because the given percept tells the agent what is the situation right now, and immediately the agent has to perform an action. What action I should do now? Because it is simple reflex, so there is no need to think about you just go for the respective action. And therefore we have a condition action rule set. So whenever we have all the conditions with ourselves and we know exactly what actions has to be performed or must be performed, then we can formulate a condition action rule set. And in that manner, there is no need to think about. So that is why we call it simple. Normally, agents where we have structured decisions, there you can apply the simple reflex agent. When we move forward, we can see the next one. The next type is called reflex agents with states. And the other name of this model is called model-based reflex agent. So we also call it model-based reflex agent, and we also name it reflex agents with state. Both are the same. Both are the same thing. So in this model, what is the difference between the previous one? Now you can see from the previous one, there is one difference, that on the left hand side, you can see there are three things which emerged. One is called the state. Number two is how the world evolves and what my actions do. This was not present in the simple reflex agent. Why? Because in the simple reflex agent, there is no need to model the situation. There is no need to see the situation. So here, when sensor takes an input from the environment, that situation has to be analyzed. It is not as simple that you have the situation and you apply the action. Rather than you will see that what state is this and how that world evolves, over with the action. Excuse me. So how the world evolves and what my actions will do. What normally actions do, but when we make an action, it means we change the state. So how the world evolves means, what world means state. So we are in one state, but what will happen if I take this action? So it means I am analyzing the situation कि मैं इस बॉक्स से इस बॉक्स में जा सकता हूँ, इस बॉक्स से इस बॉक्स में जा सकता हूँ. तो क्या होगा कि अगर मैं इस बॉक्स में जाता हूँ, और क्या होगा कि मैं इस बॉक्स में जाता हूँ. That is called situation analysis. So what we did is we in this particular model, we will analyze that particular situation, then we will decide about the action. That is the second type. And when we go to what the third type is called goal-based agents. The goal-based agents, what is different from the previous model is that in the goal-based agents, number one, the target is basically to achieve a particular goal. And whenever we design any agent problem, the goals are normally categorized into two possible categories. One is called the implicit goals, and the second one is called the explicit goals. When I say explicit goal, it means the goal itself or the target state itself is given, and you have to search it out. For example, if we are talking about a search agent, and we start from UBIT, which is our starting node, and I say you to reach out to let's suppose to tower. So tower is what is explicitly given to you, that this is your goal state. or this is your target state. Or let's suppose if you are playing a game, let's suppose there is a grid of 3 by 3 grid. So we have 9 cells, and if I ask you to place the 8 numbers in a manner that in the descending order, so I have given you the state that you have to find out the target state which is in the descending order from 8 to 1. So explicit states are always well stated, given, and there we have to match the state and to see that whether we have achieved the goal or not. But in terms of when I say the implicit states does not have the explicit criteria. Let's suppose we have discussed the example of vacuum cleaner. So in the vacuum cleaner, there is no need to give an explicit state. So the the implicit state is there. That is that we have to clean the environment. So every time when it is cleaned, it means we have achieved the goal. We have achieved the target. So in both ways, you have to go for your goal. You have to go for your target. So here the sensor will take input from the environment. That is what the world is like now. How will we know what the world is like now? By the input. We talked about the vacuum cleaner example. Let's suppose vacuum cleaner is in room A and there is a dirt. So that is the situation, that is the input. इसका मतलब है कि इस input में, इस environment में जिस वक्त वो exist करता है, यहाँ dirt मौजूद है. That is the representation of the world. Okay, let's suppose if you are playing a game, whatever the situation on the board, after your opponent make a move, is what is the state, is the given state. So that represents what? That represents what the world is like now. So it means what is the state right now. And the same thing comes over here, the situation analysis. What is the state? How the world evolves. ये वर्ल्ड कैसे, ये स्टेट कैसे आई है? तो स्टेट कैसे आती है? स्टेट आती है जब हम कोई एक्शन लेते हैं, और अगर मैं कोई एक्शन लेता हूं तो क्या होगा? मैं किस स्टेट में चला जाऊंगा? बिल्कुल वैसे ही है जैसे लेट सपोज यू आर प्लेइंग अ सिंपल गेम टिक टैक टो. आपकी टर्न आती है तो आप सोचते हैं ना कि यार मैं अगर ये चलता हूं तो क्या होगा, अपोनेंट क्या करेगा, मुझे ये मूव चलनी है, तो मैं किस स्टेट में जा सकता हूं, अगर मैं ये स्टेट चलता हूं तो मैं किस स्टेट में जा सकता हूं. सो यू ऑलवेज थिंक अबाउट द सिचुएशन. Okay, and that will give you the analysis that what it will be like if I do action A. Let's suppose if you picked out action A, then you will conceive a situation that what will happen if you choose this action A. Let's suppose if you are driving a car and you have multiple options. Either you can cross a car by an overtake, or you can just slow down your speed and wait until the next car moves to the right or left, or there is maybe the other option. So you have to pick out one of the option which is best for the given environment. And one thing which is important in the goal-based agent is that your action will always be determined, which always be calculated in terms of your path, whether you are going towards the goal or you are going away from the goal. That is the basically target in this particular goal-based agent, that whether your action will take you towards to the goal or it will take you away from the goals. ऐसा भी हो सकता है कि आप एक्शन लेते जाएं पर चल आप गोल से दूर जा रहे हैं. तो अगर आप गोल से दूर जा रहे हैं, टारगेट से दूर जा रहे हैं, तो ऑब्वियस बात है कि आप ऑप्टिमल वे अचीव नहीं कर सकेंगे ना. तो गोल बेस्ड एजेंट्स में that is important that we have to achieve the goal. So that is the third type we have. So we have then we have the learning agents. That is the most complex type of an agent, and this learning means, whenever I say learning, in the first class, in the first lecture, in the second lecture also, we have discussed this thing in the class as well, that whenever we talk about intelligent behavior of let's suppose when we talk about humans, so we have we have this capacity to learn from our experience. So whatever we do, our mind actually updates that information, and whenever we repeat that same thing. Obviously, the past experience help us to take the decision. Let's suppose if we did something wrong in the past, in the let's suppose previous try. So when we come towards the next day, what we'll do, we'll try to improve it, whether we are driving, whether we are playing game, or whether we are talking about any other type of activity in human life. So we always improve. That is the inbuilt capacity of, you can say, our brains. And by using this capacity, obviously we improve our performance. That is the main task. So here in this learning based agents, actually how it works, it takes input from the environment, the same thing. Obviously, the input will always be taken from the environment, whether you are using the vacuum cleaner, whether you are playing a board game, whether you are driving a car, whether you are talking about a traffic intelligent traffic agent. What is happening? There is always an input from the environment. So there is input from the environment based on the sensors which you have decided for a particular agent to take that input. So once the input is there, you can see the input is transformed into two components of the learning agent. One is called critic and the second one is called performance element. What is critic? Critic is something which is considered to be a component which is experienced and which knows exactly what is happening in that particular domain. So what critic will do? Critic will analyze it. How it will analyze it? It will analyze it based on the performance standard. For the given performance standard, the critic will analyze and the critic will give the feedback. So in normal process, when you talk about human intelligence, ऐसा ही तो होता है. जब मैं ड्राइविंग सीखता हूँ तो जाहिर बात है, पहले मुझे ड्राइविंग नहीं आती तो मैं किसी की हेल्प लेता हूँ. जब मैं किसी की हेल्प लेता हूँ और मैं ड्राइव करता हूँ तो वो मुझे बताता है कि ये तुमने गलत किया है, यहाँ तुम्हें गाड़ी इस तरह चलानी थी, यहाँ तुम्हें रोकना था, यहाँ तुम्हें मोड़ने से पहले ये तुम्हें यहाँ से इतनी स्पीड में करना था, तुम्हें क्लच को ऐसे रखना था, तुम्हें गियर इस गियर में होना चाहिए था. व्हाट इज दैट? That is basically a job of a critic. It helps you to make your actions correct. And obviously, that critic has a knowledge of that particular domain. So, whenever the critic explains you, a critic always considers the performance standard of the given problem. अभी मैंने गाड़ी चलाने के लिए क्रिटिक की बात की थी. Let's suppose if you are a football player, so you have a coach. So whenever you are playing a match or whenever you are in the practice, what coach will do? He will always tell you that you did this thing, you did this thing wrong. You have to go in this manner. You have to move in this manner. Why he is doing this? Because he is the expert of the field. So according to the standard and norms of the game, he is telling the players how they can improve. That is the task of the coach. That is the responsibility of the coach. So because he is an expert, so let's take another example. Being a human, let's suppose we want to write a poetry. So we are not actually poets. So if we write a poetry, we don't know exactly what is the criteria of writing a poetry. इसमें पहला सेंटेंस क्या होना चाहिए और मक्ता क्या होना चाहिए और किस तरह से उसको वोकैबुलरी कैसे इस्तेमाल होनी चाहिए, किसी ख्याल को कैसे रिप्रेजेंट करते हैं. So what we will do when we write some poetry, we will share it with the person who knows the poetry very well. So what is the advantage of this? So that person will let us know what is wrong in the poetry. So if we improve it, our learning will start. The next time when I will make that poetry, I will make sure that I will not make that mistake. Maybe I will have another mistake. बिल्कुल हो सकता है गाड़ी चला रहे हैं, आज ये गलती की है, वो आपको समझा रहा है कि ये गलती की है, हो सकता है अगली दफा कोई और गलती करे फिर वो समझाएगा. So it's a continuous learning is always a continuous process. It never ends. आप किसी डॉक्टर से कहें कि तुम आज एक्सपर्ट हो गए, वो कहेगा नहीं यार मैं आज एक्सपर्ट नहीं हुआ, मुझे 20 साल हो गए लेकिन मैं समझता हूँ मैं आज भी एक्सपर्ट नहीं हूँ, इन चीजों की मुझे अभी भी नॉलेज नहीं है या कम नॉलेज है, मैं नहीं कह सकता श्योरिटी से। आप किसी इंजीनियर से कहेंगे तुम इतने एक्सपर्ट हो कि हर तरह की जो है ना चीजों को डिजाइन का हर तरह के पुल को डिजाइन कर सकते हो, तो वो भी कह सकते हैं नहीं ऐसा नहीं है। बिकॉज लर्निंग इज अ कंटिन्यूस प्रोसेस, यू हैव टू अपडेट योर सेल्फ with respect to knowledge, with respect to standards, and only then you can. So the same thing happening over here. We have the sensors which takes input from the environment. The critic will take the performance standards. The performance element pass this knowledge to the learning element. Whatever the knowledge which is there to perform or take an action, that will be passed to the learning element. Learning element will receive the feedback from the critic. That feedback is actually important, that that will basically tells the agent how to respond in that particular situation. So for any given situation, if agent is unaware, the critic will update the information, and that updated information जिसको हम कहते हैं नॉलेज अपडेट करना, या नॉलेज को जैसे जो मेरे पास एग्जिस्टिंग नॉलेज है वो क्या हो गई, वो अपडेट हो गई और नई नॉलेज इनकॉर्पोरेट हो गई। तो हर दफा एक नई नॉलेज एक नए सिस्टम के अंदर ऐड हो जाती है। लर्निंग इसी को कहते हैं ना। लेट सपोज कि मैं जो है वो एक डॉक्टर की एग्जांपल मैंने पहले भी दी थी कि वो पहली दफा एक एमआरआई को रीड कर रहा है और उसको असेस कर रहा है। तो पहली दफा जब रीड करेगा तो ऑब्वियसली जो आउटपुट वो जनरेट करेगा वो बहुत एक्सपर्ट आउटपुट नहीं होगी, लेकिन अगर वो एमआरआई 10 एमआरआई कर चुका होगा तो उसकी एक एक्सपर्ट ओपिनियन में और बेहतर हो जाएगा। अगर वो 100 एमआरआई देख चुका होगा तो एक्सपर्ट ओपिनियन उसका और बेहतर हो सकता है। और अगर उसने 500, 1000 या 2000 एमआरआई देख चुका है तो इसका मतलब है उसका जो ओपिनियन होगा या उसकी जो एक्सपर्ट एडवाइस होगी वो ज्यादा बेहतर हो जाएगी। ठीक है, तो जितना ज्यादा हम लर्न करते हैं, जितना ज्यादा, इसको दूसरे लफ्जों में मशीन के लिए जो हम टर्म इस्तेमाल करते हैं वो हम कहते हैं जितना ज्यादा मशीन ट्रेन हो जाती है, द मशीन विल रिस्पॉन्ड बेटर। वो जो एरर का रेट है वो बहुत रिड्यूस हो जाता है, बहुत कम हो जाता है। क्यों? जब हम ट्रेनिंग को इंक्रीज कर देते हैं। So learning element will make the learning goals. What are the learning goals? What we have learned, and the problem generator will generate that situation, which will be passed out to the performance element, and performance element execute that particular task. तो लर्निंग बहुत सारे तरीकों से की जाती है। मसलन लर्निंग को अप्लाई करने के लिए मशीन लर्निंग का पूरा एक कॉन्सेप्ट है। उसके अंदर मिसाल के तौर पे एक टेक्निक है, उसे हम कहते हैं आर्टिफिशियल न्यूरल नेटवर्क्स, ANN। तो हम ANN अप्लाई करके भी लर्निंग कर सकते हैं। ठीक है, और इसके अलावा और बहुत सारे मेथड्स हैं मशीन लर्निंग में जिनके थ्रू हम लर्निंग करवा सकते हैं मशीन्स के अंदर। ठीक है, तो लेकिन जो बेसिक उसका जो प्रिंसिपल है, दैट प्रिंसिपल और जो फंडामेंटली जिस तरह वो वर्क करते हैं, दैट विल रिमेन द सेम। सो दिस इज अबाउट so we will start our discussion regarding chapter number 7 of our book, and this is considered to be a very important chapter as part of our syllabus is concerned. So the name of the chapter is logical agents. Okay, so obviously we will talk about logic here. So what is the outline of this chapter? The outline of this chapter includes, number one, we will discuss the knowledge base agents. What are the what is knowledge base agents? We talked about agents in the second chapter, but here we will focus on the knowledge base agents. Then you can see there's a concept of Wumpus world. Wumpus world is nothing but it's a game scenario, it's a situation, and that is given in the book because obviously it is easier for us to understand anything in terms of an example. So Wumpus world is an example which is there, so it will help you out to understand the concepts of the logic. Number 3, you can see the logic in journal. What logic is? Here we will define the logic and important terminologies which are related to logic, which includes the models and the entailment as well. Then the logic which we will discuss in chapter number 7 is called the propositional logic. So there are various forms of logic, but in chapter number 7, The focus is on the propositional logic, which is considered to be the simplest form of logic, and also we can say it Boolean logic because it is represented in terms of true and false. Then we will see the concepts which are related to logic, that is equivalence, validity, satisfiability, and other terminologies as well. And then in the end, we'll talk about the inference rules, how we make inference in the logic. When I say that there are some sentences given, how you come out with the conclusion, how you make the conclusion. So it is based on forward chaining, backward chaining, and there is one principle which is called resolution. So this is the outline of the chapter. And so we talk about knowledge base first. What knowledge base is? So knowledge base is basically, you can say, is the set of sentences in a formal language. When I say it's a formal language, it means any language which has its own syntax, it has its own semantics, that is said to be a formal language. For example, when I talk about natural languages, so natural languages are itself, they are formal languages. When we talk about Urdu, तो Urdu का एक पूरा structure है. Urdu includes the grammar, Urdu includes the vocabulary, how to construct the sentences. So it's a formal structure. If you talk about in the natural language, if you talk about English, so English has its own formal structure. अगर आप गलत लिखेंगे तो लोग आपको फौरन बताएंगे कि ये गलत लिखा है आपने, इसको ऐसे नहीं ऐसे डिस्क्राइब करते हैं. Similarly, when we talk about knowledge base, so knowledge base is also described in a formal language. But when we say a formal language, it means we are referring here the logic, because logic itself is a language. So even you can write the sentences in a natural language, but you have to convert those sentences into the sentences in the logic. And obviously, we are not talking about a single sentence. It's actually a set of sentence because we are talking about a knowledge base. So knowledge base includes number of sentences. And when I say sentence, sentence means either a fact or a rule. So you describe a fact, it's a sentence. For example, if I say in the knowledge base, if I say that if for example, if I say the agent is located in A, so this is what, this is a fact. That fact is described in terms of a sentence, but there are other facts as well. When we talk about a knowledge base, obviously it is not, we are not talking about one sentence or two sentence. It's a set of sentences. एंड ऑब्वियसली जब हम कहते हैं ना सेट ऑफ सेंटेंसेस, तो उनके दरमियान कोई एक रिलेशनशिप बिल्ट हो रहा होता है, उनके दरमियान एक जो है ना, ये नहीं हो सकता कि मैं एक बात करूं जो है ना मशीन डायग्नोस्टिक की एक सेंटेंस और दूसरा सेंटेंस मैं लिखूं ह्यूमन डायग्नोस्टिक का, तो ऐसा नहीं हो सकता ना, दोनों चीजें डिफरेंट है. तो नॉलेज बेस जब भी हम बिल्ड करते हैं, वी आर स्पेसिफिक. तो दैट इज व्हाई द नॉलेज बेस whenever we build the knowledge base, actually we have two components you can see on the slide. Number one is called the inference engine and the second is called the knowledge base. The inference engine itself is based on domain independent algorithms. Inference means how to retrieve or how to conclude from the given knowledge, that is based on the inference. आप एक इन्फ्रेंस रूल लगाते हैं और फिर ये साबित करते हैं कि हाँ ये सही है, ये गलत है, या ये चीज इससे इन्फर हो रही है, ये वैल्यू आएगी, इसको यहाँ जाना चाहिए था, इसको ये करना चाहिए था. दैट इज सम inference you make from the knowledge. And for making inference you need some algorithms, and that is why the algorithms have nothing to do with the domain, whatever the domain is. Let's suppose aapne knowledge, if you have created a knowledge base for machine diagnostic, does not matter. If you make a knowledge base for example medical diagnosis, does not matter. If you have a knowledge base for kinship domain or family domain, does not matter, because all these algorithms work domain independently, means there is nothing to talk about the domain. But the knowledge base which you create, which is actually the set of sentences, is always domain specific. Let's suppose if you are building a knowledge base for machine diagnostic, so obviously you will include all the facts and rules which are related to machine diagnostic. If you are constructing the knowledge base for disease diagnostic, then or for medical diagnosis, there you will have the set of sentences related to that particular disease or the rules which are related to that particular disease. So that is why we have two components, inference engine and the knowledge base. So declarative approach to building an agent, how we use the declarative approach. And that declarative approach, there are two ways by which we can do it, declarative approach and procedural approach. So here, whenever we are constructing this knowledge base, we are talking about the declarative approach. There is no procedural approach. So here we have a special kind of relationship that is called tell and ask relationship. Tell is what it needs to know. Tell is what it needs to know. Means tell means informing the knowledge base, and ask means to make a query to find out. Or obviously, when you find out, the inference algorithm will run, and you will know whether what is the result of your query. So tell is what it needs to know, and the ask itself what to do. Answer should follow from the KB. Obviously, all those answers will follow from the KB. Agents can be viewed at the knowledge level, but they know regardless of how they implement it. That is important. Whenever we talk about any agent based on the knowledge, so the most important thing is what you have, what knowledge they have, and what knowledge they have means what facts you have described in that particular context. तो अगर आपने वो important fact नहीं रखे हैं और बहुत कम fact रखे हैं तो less knowledge होगी. मैं आपसे कहूँ कि आपकी कितनी knowledge है AI में, तो आप जितना ज्यादा एग्जिबिट करेंगे और आप जितनी चीजों को अच्छे तरीके से रिप्लाई करेंगे, मैं कहूंगा अच्छी नॉलेज है. जितना कम एग्जिबिट करेंगे और जितने कम फैक्ट्स आपको मालूम होंगे, तो मैं क्या कहूंगा कि और लेस नॉलेजेबल. बिल्कुल सेम चीज है. एजेंट को जब हम डिस्क्राइब करते हैं बेस्ड ऑन द गिवन नॉलेज, so obviously they are which determined in terms of what they know. And at the implementation level, the data structure in KB and algorithms that manipulate them. And when we implement, obviously the data structure, how we represent that knowledge, किस तरह से represent करेंगे, जो है representation का जो wave out होगा वो क्या होगा, that is based on the structure itself, and then it can be implemented in any language or a tool by which we can see the results, and later we can see how we can do it. So we have the tell and ask relationship, and the same thing is represented in terms of the function, a simple function. You can see a KB agent is a function. What is the input? The percept is the input, and what it returns? It returns an action. So it is static, it is not dynamic because these are already described. So it is based on the simple percept. So we have the KB, the knowledge base, T, a counter, because it changes when T is 1, when T is 2, when T is 2. Initially, let's suppose it is 0. So what we are doing, we are telling the knowledge base. Telling means informing the knowledge base, or you can see adding information to the knowledge base. So what is what we are telling to the knowledge base? Make the percept sentence, percept T, at any given point in time. That is, we are informing the knowledge base. So what action is required? That is ask relationship. Let's suppose if we have a particular percept, what action the agent should take. So if agent takes an action, what will happen? You see yourself that your T will be T plus 1. So why? Because the agent moves to that particular state, and that is T plus 1. So if the agent goes to the new state, so it must have a new percept, and in the same manner it acts. So the agent must be able to represent states and actions. That is very important. Incorporate new percepts. All the time you have new percepts. जरूरी नहीं है percept fix हो. New percepts arise हो सकते हैं. Or if new percept arises, obviously that will informing the knowledge base. Update internal representation of the world. So internal representation of the state will change when you have the new percept. Deduce hidden properties of the world. So there are some things which are not explicitly there, but you have to find out from the given problem. That is called deduction. And all those properties which are hidden, but you will take out these hidden properties as well. And obviously, for all those situations, come out with an appropriate actions. So that is the concept of simple knowledge